Subject name: Design with linear integrated circuit and application. Chapter name: Operational amplifier. Topic name: Basic of operational amplifier. In this video we're gonna discuss about basic of operational amplifier. Before that, the first operational amplifier in the integrated circuit form was brought in the market by the franchise company. The name this op-amp as 741, which became extremely popular and was used in variety of applications. The operational amplifier is a linear or more accurately an analog integrated circuit. So what is meant by actual operational amplifier? With the help of operational amplifier, we can perform the basic mathematical operation such as addition, subtraction, multiplication and integration. That's why it is called operational amplifier. Operational amplifier is used to amplify the DC signal as well as AC signal. With the help of suitable external component, we can use operational amplifier for various applications such as regulator, comparator, active filter and so on. Symbol of operational amplifier. Here is the symbol of operational amplifier. This arrowhead signifies the flow of current from input to output. Here is the some symbol, that is inverting input, non-inverting input, plus VCC, minus VCC and the output. Now all the operational amplifier contain at least 5 terminals. Which are they? Plus VCC, minus VCC, non-inverting, inverting and output terminal. So first to this plus VCC and minus VCC, nothing but your supply voltage. Now looking for these inputs, inverting input nothing but signifies the negative sign, non-inverting input signifies the positive sign. So what is meant by this inverting input? Here is, if we apply input to inverting terminal, we will get phase shift signal at the output, or we can say that 180 degree, and remaining next terminal should be grounded. This is nothing but your inverting. This is nothing but inverted output signal. Now next, if we apply input to the non-inverting terminal, we will get same signal with the same phase with the output. This is called as a non-inverted output signal. Going for the next. Pin diagram of IC741. Look at that. This is the pin diagram of IC741. It's a 8-pin IC. In that, pin number 1 and pin number 5, nothing but your offset null. Pin number 2 and 3 called as an input terminal, named as inverting input and non-inverting input. Supply voltage plus VCC and minus VCC. And last terminal nothing but 6 number output. And here is the pin number 8, no connection. Going for the next. Equivalent circuit of operational amplifier. Or we can say that this is the ideal operational amplifier. Here is the circuit explanation. This is the input area. Input area consists of non-inverting V1 terminal and inverting, that is V2 terminal, is connected through input resistance Rin, or we can say that the Ri, input resistance. Now this is nothing but your output section. In output section, You have to connect the voltage, that is V0, from plus to minus. RO nothing but your output resistance. In that you have to connect it, that is AOL into VD, stands for open loop gain and difference voltage. And power supply is connected, that is plus VCC and the minus VCC. Figure shows the equivalent circuit of operational amplifier. It included the important values, that is AV, RI, RO, etc. Note that the AV and VD, that is the average voltage gain and voltage difference, is the equivalent Thevenin's voltage source, and RO is the Thevenin's equivalent resistance looking back into the output terminal of operational amplifier. Now the value of input resistance Rin is finite here, and that of the output resistance Ro is non-zero because the op-amp is non-ideal. Now let us discuss the parameter of Ri, Ro, AV are called as the open loop parameter. What is meant by the difference voltage VD in this? That is VD is equals to V1 minus V2. It is called as a differential input, and AV is called as an open loop gain. Hence, the output voltage is given by output voltage, that is V0 is equals to AV into VD. That is equals to AV, VD stands for your V1 minus V2. So AV in bracket V1 minus V2, this is the output voltage with respect to ground. Now next, very important, that is important characteristics of operational amplifier. Now first operational amplifier, first characteristic of operational amplifier is infinite voltage gain. The open loop gain of operational amplifier is denoted as AV. It is a differential voltage gain and its value for ideal op-amp is infinity. Second characteristic of operational amplifier is infinite input resistance. The infinite input resistance, due to this, the current flowing in each input terminal will be 0. That is IB1 minus IB2 is equals to 0. Due to infinite input resistance, almost any source can drive it and there is no loading of the source. Next characteristic, zero output resistance. The output resistance RO of ideal op-amp is 0 due to zero output resistance. The ideal op-amp can drive infinite number of other devices. Next characteristic, that is zero offset voltage. In practical op-amp, a small output voltage is present even though both the inputs V1 and V2 are having a 0 volt. Next characteristic, that is infinite bandwidth. Bandwidth of operational amplifier is infinite, so it is capable of amplifying the signals having a frequency right from 0 to infinity. Next important characteristic, that is infinite CMRR. CMRR stands for common mode rejection ratio. An ideal operational amplifier has an infinite CMRR. That means its common mode gain is 0. Next characteristic, that is infinite slew rate. Slew rate of ideal operational amplifier is infinite, so that the output voltage changes occur simultaneously with the input voltage changes. The slew rate definition and its significance have been explained later. Next important characteristic, that is zero PSRR. What do you mean by this PSRR? PSRR stands for power supply rejection ratio. PSRR is a parameter which specifies the degree of dependence of the operational amplifier output on the changes in the power supply voltage. For the ideal operational amplifier, PSRR is equals to 0. That means the output voltage does not change due to fluctuation in supply voltage. Thank you.